Hey guys, it's Mary and welcome back to Study Journey. Welcome back to the Python series. This is episode 9 of the Hangman series. And in the previous episode, we finished up on user input requirements and now we're going to be moving on to game rules. So without further ado, let's get on with the video. Last episode we talked about the user input requirements and now we will be talking about the game rules. So if we go to CS Practice, which is my folder where I keep everything, we can open Hangman files and I have all of the downloads in here. So I'm going to open up the instructions and as we can see it is on the page where it is called game rules. And before we have done the game requirements and we talked about the game architecture and the user input interaction and also the user input requirements. Now part D is the game rules. A lot of this is similar to what we have done before and it is just a summary, so we're just going to be adding on to it and doing the part that we haven't done. So it says that the user starts with 3 warnings and I'm going to open my file. It is in the folder CS Practice for me and I called it Hangman Episodes. And this is where I have written all of my previous code. And now we're just going to build onto it even more. So if I go to my main function, which is Hangman, we go down and look at my code and it says the user starts with 3 warnings. And it says the remaining warnings is 3, so that's correct. Now, if the user inputs anything beside an alphabet, you have to tell the user that they can only input an alphabet. So if they have more than 1 warning left, the user should lose a warning. Otherwise, they should lose 1 guess. And we did this in episode 7, where we defined the not alpha warning, which means if it is not an alphabet, what does it do? And then it says, part 3, that if the user inputs a letter that has already been guessed, print a message telling the user that the letter has already been guessed, and then subtract 1 warning if there are warnings and 1 guess if there are no warnings left. And that is what we did in the previous episode, episode 8, where we defined repeated guess warning. Now that we have done this, it says in the next part that if the user inputs a letter that hasn't been guessed before and the letter is in the secret word, the user loses no guesses. But for consonants and vowels, it loses different numbers of guesses. So if it is a consonant and the user inputs a consonant that hasn't been guessed, but the consonant is not in the secret word, then the user will lose 1 guess. And if it is a vowel, then the user should lose 2 guesses. Now it tells you that the vowels are A, E, I, O, U, and Y does not count as a vowel. And then it shows you an example implementation. So this is what our code should look like by the time we are finished writing it for this episode. So if we go to our side into our main code, let's see where we are going to implement the consonant and vowel point deductions. So I'm going to expand my code, and as we can see, this code basically reads, it gives you the number of warning and number of guesses, it prints out how many warnings you have left, and if the remaining guesses is greater than 0, it's going to print out how many guesses you have left, the available letters, and lets you input a letter. If it is not an alphabet, which is what we did in episode 7, then it updates the remaining warnings and remaining guesses based on what we had in not alpha warning. However, if the letter has been guessed and the current guess and the letter guess is the same, which means there is a repeated guess, it implements the repeated guess warning and updates the remaining warnings and remaining guesses once again. However, else, which is a continuation of this if right here, so if it is not a repeated guess, then what does it do? If the guess is a letter and it has not been guessed, what should it do? Well, it updates the current guess, and then if the letter was guessed, you say good guess. If not, you say oops, that letter is not in my word. But now as we can see, we have to update the else part because if it is not in the word, there are 2 scenarios. Either it is a consonant and you lose 1 guess, or it is a vowel and you lose 2 guesses. So we have to write another function to put right here instead of just saying it is not in my word and giving the word. So instead of saying this, we have to update this. So before the Hangman function, I'm going to define another function and I'm going to call it wrong letter guessed. So if there is a letter guessed and has not been guessed before, but it is not in the word, what should it do? Well, there are 2 case scenarios, either it is a vowel or consonant. So the input is what we are going to be using in this function. And as we can see, we are going to be comparing what we are guessing right now. So the current guess, then we have to update the remaining guesses. So that is going to be input, and then we are also comparing it to the secret word, so secret word, and then also letters guessed to see if it has been guessed or not. Colon indent. So I'm going to write a pseudocode, which basically just resembles a simplified programming language, And it is just a representation of code that can be understood by someone on a basic level without actually implementing everything. We can use this first to give us an order of logic and then implement our logic into actual code. So basically, because there's two scenarios, we can separate it to an if and else condition. So whether if it is a vowel, otherwise it is going to be a consonant, because in our alphabet there's only vowels and consonants. So if it is not a vowel, it's going to be a consonant. And it's easier to define vowels, so I'm going to set vowel to A, E, I, O, U. So we know that this is our vowels. So I'm going to write my pseudocode after hashtag, which means that it is a comment and it is not actual code. So if is letters guessed, or if the letter guessed is a vowel, then we are going to subtract 2 guesses from them, because if it is a vowel, they lose 2 guesses. So the remaining guesses is going to be updated to remaining guesses minus 2. And then you're going to tell the user that letter is not in my word. So I'm going to print that letter is not in my word, and then colon, close quotes, and then it gives you the word. So we're going to do comma and then the get guess word. And I'm going to update whatever is inside after. Okay, so if it was a vowel, this happens. Else or otherwise, or basically when it is not a vowel, which means it is a consonant, what do we do here? Well, if it is a consonant, then we are just going to update the remaining guesses to remaining guesses minus 1 instead of minus 2. So it should also print out that that letter is not in my word, and then it's going to give you the word. So now that we have this, we know a general flow of what our code is going to look like, and we're going to make this actual code instead of code that cannot be actually implemented into the function. So the first part, it can stay the same, and for the first line, instead of saying if is letter guessed is a vowel, we can update this to say if is letter guessed. So if the current guess that you're guessing right now is a vowel, colon, and then we can get rid of the hashtag. So the current guess you have right here, if this is a vowel, then this will happen. So remaining guesses will subtract 2. And this is correct notation. However, if it is not, then we're going to print that letter is not in my word and then the get guess word. For the get guess word, the 2 parameters, like always, are the secret word and then the letters guessed. Otherwise, so else, when it is not a vowel, we can delete this because you just say if and then the else is just else and then a colon, and then indent. We print that the remaining guesses is 1 less, so that is correct notation, and then we're going to print that letter is not in my word and then the get guess word. So we can copy this over. And now that we have this, we have to return what we are trying to update. So because after we implement this, it should update the remaining guesses to either subtract 1 or subtract 2. We have to return the remaining guesses. So now that we have this, we can use it in our code down here. Instead of just saying that letter is not in my word, we have to update this so that it is going to be using the wrong letters guessed. Like in the previous 2 episodes when we updated the remaining guesses and remaining warnings, right here, since we are only returning the remaining guesses, we can just update the remaining guesses. So remaining guesses is equal to what this will give out if we implement wrong letters guess, which is the remaining guesses that you have left. And now that we have this, we can save our code and then run it through our terminal. As always, because my file of Hangman episodes is in my folder of CS Practice, I open my folder of CS Practice by saying cd CS Practice. Now that I am in this folder, to open up the file, I will type python3 and then the name of my file, which is Hangman episodes, and then .py to indicate it is a Python file. Now let's compare it to the example implementation. So it says, so let's type in a letter that we already know it is going to be in the word. So above this, for testing purposes, we have set the secret word to apple. So when we're going to run this, if we say A, it should be in the word. However, if it is a wrong letter guessed, so if it is not A, P, P, L, or E, let's say we type in the vowel I. Let's see what will happen. It subtracts 2 guesses because it is a vowel, and it says that letter is not in my word. And that is correct because this is what they did right here. And it went from 5 guesses to 3 guesses because they started off with 6 guesses. Now let's type in a consonant. So for example, K. So it says that letter is not in my word, and it subtracts 1 guess because it is consonant. So now that we have this, we know that our code is correct, and we have updated our code. So it not only takes off points for if you have a repeated guess or if it is not an alphabet, but it also has different guesses that it takes off for whether it is a consonant or a vowel. Alright guys, that is going to be it for today's video. We talked about the game rules, and in the next episode we're going to be moving on to game termination, so what to do when the game ends, and then also how to calculate the total score. I hope you enjoyed, and thanks for watching.